Some of the material in Chapter 2 is an extension of what we learned in the solid state classes, but there are some differences in drawings, and so we will only concentrate on op amps. Here's an inverting op amp, and we know it's inverting because we're going into the negative input. The gain is RF or Rn, in this case 10 kiloohms divided by 2 kiloohms, and we say it's negative 5, and the negative indicates that it is inverting. If we have an input of 2 volts, and then we can calculate the output by simply saying it's 2 volts times 5, which is 10 volts, and we say it's negative 10 to indicate the inversion. But this op amp can amplify either DC or AC. The summing amplifier is very much like the inverting amplifier, but there are 3 different gains, and they're calculated in the same way: RF or R1, or RF or R2, or RF divided by R3. Let's say Vn1 is 2 volts and Vn2 is 1 volt and Vn3 is 3 volts. Then it's very easy to calculate the output voltages. As you can see, 2 times negative 1, 1 times negative 1, 3 times negative 1. And then what we simply do is take all the output voltages and add them together. We can sum them together and we have negative 6 volts. A differential amplifier is used to amplify the difference between the two inputs. Most of the time, we use a differential amplifier to amplify very small signals, and that is why we have a high gain. See, in this case, it's RF divided by RA for a gain of 100. Notice that RF equals RN and RA equals RB. In this example, we are amplifying a DC signal, but in general, the differential amplifier is used with working with microphones and sensors where the signal is very, very small. A non-inverting amplifier takes the signal into the positive input, and for that reason it does not invert the signal. The way I have drawn the circuit is a better way as opposed to the book, which seems to draw the thing upside down. The gain is calculated as RF divided by Rin plus 1. In this case, 100K divided by 10K plus 1 equals 11. RC is called a compensating resistor, and it's not really necessary. And when it is used, it's only when you have very small signals, and then it must equal Rin.